Alright, guys. Let's keep working. So we've got finance questions here. They say an investment it earns an interest rate of 7.5 percent PA, right, per annum component quarterly. Calculate the effective rate. Calculate the effective rate. Come on, bro. Effective annual interest rate. Yeah, which is the effective rate anyway? Cool. So the thing is, while I'm teaching this, I don't know if you guys, if they give you formulas, for finance, but the unfortunate thing that could happen is you forgetting the formulas when you are writing if they don't give you the formulas. But here's a trick for the one we are dealing with, right? So just remember, for this one you have simple interest being equated to compound interest, right? That's how we get the formula. It's like p1 plus I, no, yeah, okay, let me just say n, right? Oh, I'm coming back. And then equals to, you have p1 plus I, then m, right, and m, right? Cool. So the thing is, this is the idea, you have your simple interest equation being equated to your compound interest equation, but as for a number of years it's 1, right? So you have n being 1, so when you go down the next step, the p's are going to cancel, and then you equate, so p are going to cancel, and n is equals to 1. So that means you're going to have 1 plus I equals to 1 plus I m over, yes, I over m, right, all to the power of m, right? Let me put it down a bit. Yeah, and then you have the formula, right? You just know this is the effective rate. So I'll just say EFF and then this is the nominal rate, right? Yeah, so of course, since we're looking for the effective rate, you're gonna have IEFF equals to 1 plus IN minus 1. Then substitution 1. Remember now it's 7.5, so that is 0.075. Cool. Divided by compounded quarterly, so it's 4, and then to the power of 4, right? Time is 1 if you still want to include n, which is equals to 1, which is kind of pointless to actually include minus 1. So then your effective rate, one, two, yes, 4, 4, let me see, minus 1, I win. So we're getting 0.077 135, let me just say 9. Yeah, so therefore now let's write it in a percentage form. Have 1 2, so it's gonna be therefore I EFF is gonna be 1 2, that's 7.7, just 7.71. So therefore I could remove these numbers at 7.71%. Right. And remember, by definition, what is this? Effective rate is the simple interest. Yes, the simple interest rate. Simple interest rate doesn't make sense. Yeah, but the interest rate that we use in a simple interest, that gives you the same accumulated amount, right, of the interest in your compound interest. I hear the English is actually killing me. How do we actually say that? That the effective rate is the interest rate used in a simple interest formula that gives you the same accumulated amount as the interest rate used in the compound interest formula. But yeah, so that's the idea, né? Let's go to the second question. So the second question, they say rhino poaching is a serious problem, of course, and has resulted in the black rhino becoming an indigenous species. Okay. Statistics shows that there were 60,000 black rhinos in the 1970s and only 4,200 remaining in 2011. Determine the annual rate of the population decrease. Population decrease, right? Yeah, so we determine the annual rate, which is the the annual rate of the population increase as a percentage over these 42 years. Cool. If the rate is compound decay. So here they gave us a clue of perhaps what formula we will use, right? It's gonna be that compound decaying formula or the reducing balance formula. But if they didn't say, the thing is, you know your finance very well, right? And you know, this is in grade 11, right? In grade 11 we did mention it. We were like, population growth. Yeah, population growth is actually we use compound interest, right, to make calculations regarding population growth. So, and by population growth also population decrease also is included, right? So you would know that we're going to use a compound formula, the compound interest formula here, right? But of course this one is a reducing balance. So you have a what else, p into 1 minus I, right? And we make our substitution. We had 60,000, right? Yeah, so we had 60. This is gonna be 60,000 into 1 plus, oh no, minus I. This is the I we're looking for. And then n is what, from 1970. They said 42 years, so I'm gonna take it as 42 years also. 42, let me actually confirm. 2011 minus 1970, it's actually 41. But like, yeah, they're asking me to do this calculation over 42 years, but it won't make sense, bro. Cause look, in 1970 there were 60k rhinos there, and only 4,200 remaining in 2012. So because now here I'm gonna put 4,200, you see, because this is what's remaining in 2011, and then the whole entire duration, it's been 41 years, ne? From 1970 to 2011 it's been 41 years, not 42 years. So it doesn't make sense for me to even use these figures, because then this is fine, but then for here maybe I would have to use the figure for 2010, right? Because I feel like if it's 20, not 2010, 2012, yeah, if it's 2012, then it will be 42 years. Yeah, so guys, here, if I was a marker, I'm also perplexed. Look, they are saying we must make calculation for over 42 years. That is fine, we understand. But the figures, they are not for the duration of 42 years, unless during the period from 2011 to 2012, there were no rhinos that were poached, and the number of rhinos were still the same. Like, it was still 4,200. Then I'm like, I'll be okay with the way they structured this question. Yeah, well, so I have a problem with this question. Yeah, and these are the reasons why. So in that case, guys, like, it's fine if you use 41, I will give you all 4 marks, right? And even if you use 42, I'll give you all 4 marks. It doesn't make sense what they are asking here. I think there was, yeah. But it's fine, yo. That's fine. So what we have, we can just divide by this. But in fact, let me do this. Nah, I can put this there. But what I wanna do is, oh, actually, yeah. But it's fine. It's fine. Even if I don't have it, I wanna write I as a subject of the formula. So I'm gonna have A over P, right? And then I have A over P 1 over N equals to 1 minus I, right? Yeah, with no brackets. Because now if I also raise this to 1 over N, this 1 over N's they cancel, and then we just have that. Yeah, so yeah, and therefore I is gonna be 1 minus A over P to the power of 1 over N. Right, now I can substitute 1 minus 4,200, 60,000, 1 over 42. Yeah, I'm not happy with this 42. 1 minus so that means in terms of like as a percentage rate, it's going to be 6.14%, right? Yeah, 6.14%. Cool, let's move on. They say Adam inherits 27,000, which he invests in a savings account. The interest is calculated at 5.4% compounded monthly for the full period. 3 years after he invested the initial cool, he withdraw X amount to make a down payment on a car. Cool. Calculate the value of X if he accumulated this much in the savings account after 10 years. Right, cool. Of course, here we can hear that there's a timeline question there. So this is T0. T0, like he inherited the money which he put into a savings account. So we can just say plus 27,000 rand, right, at T0. And then 3 years later, right, 3 years later, T3, he withdraws some cash. So minus, yeah, he withdraws some cash to make it down payment on a car. And nothing about the car has been said afterwards. Calculate the value of X if he accumulated 17, right? So now this is like T10, right? T10. So here, right, here he ended up with this much money, you see. Yeah, in that savings account after 10 years. So what we can do is we know the money that is in the account in 10 years time, right? Yeah, we know the money that was in the account in 10 years time from the time he invested the initial from the time he made the initial investment. We know like you have at in 10 years later he has 17,614. So what we can do is we can try to find the amount that was in here. Ne? So the amount that was in here, which is the amount that I accumulated to 17k, we can find out how much it was. Yeah, well, and then what are we going to do after we have found out? After we have found out, ne? So okay, Remember now, you have X being invested for 3 years, right? Not X, bro. You have 27K, which is in the savings account for 3 years. And we have all the tools to calculate how much that is going to be, right? And that total, right? Remember, from the total, we subtracted how much? We subtracted X. And the amount that was left in the account was the one that was that stayed there for the remaining 7 years to end up accumulating this much. So that's where the logic is coming from. So let's start. So we don't know P and we are looking for P, so we can say therefore P is going to be A all over A all over, which is going to be, we had 17K one plus interest rate 0.054 compounded monthly, right? So the thing, it was 7 years, so it's gonna be 7 times 12, because from here, from year 3 to 10, that is 7. And the calculator says okay. Cool. So the calculator say we had 12,080 rands 41 cent that was left in the account. You see, so this is how much was left in the account right here. So now then we can say this. We can say 27,000, right? 27,000 invested for 3 years. Okay, let me do it step by step. So A equals to P1 plus I n 27 1 plus I is 0.054 over 12, 3 times 12. This is me finding out how much did the 27,000 I get to. So it says we had the 27,000, it reached 31,736,69. Yeah, 3 years later. So before this man made the withdrawal, this is how much was in the account, right? Then he makes the withdrawal, right? He's like, from this 31,736.69, he withdraw X, and he was left with 12,080.41, which remained in the account for 7 years to end up giving 17K. So now the math is gonna be minus 12 equals to Rx, saying that Rx will be 31. Cool. So what is this saying about our guy? Our guy withdrew um our guy withdrew 19,656 rands and 28 cents. Cool. Let's move to the next question. Actually, yeah, let's move to the next question. This is the last question we have. Um, Sipu Kazi bought a house. She made a deposit of 102K, which is equivalent to 12% of the selling price of the house. She obtained a loan from the bank to pay the balance of the selling price. To pay the balance of the selling. Cool. Um, the bank charges her interest of 9% compounded monthly. Cool. Determine the selling price. Cool. So the selling price, this is how you'd think of it, ne? So they're saying this amount is 12% of it's 12% of the selling price. So you can be like, the selling price multiplied by 12% equals to 102,000, right? So therefore the selling price is going to be 102,000 divided by 12%, which is 102,000, yes, divided by 12%, and you're getting 850k. Cool. So now they say the period of the loan is 20 years, and she starts repaying the loan 1 month after it was granted. Calculate her monthly installments. Now I'll have a question. This is an annuity question, right? Is it a future or is it a present value annuity? Remember, for present we are paying a debt, right? Yeah, and then future we are trying to secure, right? We are trying to secure some funds for the future. So now we're going to use a present value formula, which is P equals to X, right? You have 1 minus, I hope I have it right, I to the power of minus N, right? I hope I have it right. I'll just check now. And then this is going to be I for the interest. Let me check now. Cool. So the formula is right. Yeah, the formula is right. Let me do this. So this is, of course, this is of course a present value annuity, right? So the thing here is, remember, so our person had this is the selling price of the house, and then she paid a deposit of 102,000, and then the rest she went to a bank for a loan. So we need to calculate how much that is. 102. So that means she now owes a loan of 748k, right? So that is the value we're gonna put here. But now the question, before anything else, we are looking for x. So I tried to make x subject of the formula. This is just the way I prefer to work things out. Yeah, but with finance, it's nice to have already defined formula where you just substitute, calculator, get the answer done. Yeah, I hate pressing calculators many times. If you can just do it once and be done. So to make x subject of the formula, we will be multiplying both sides by I, and then 1 minus 1 plus I minus N, right? So that means we multiplying both sides by that, right? That means we're gonna have x being equals to PV times I, and then you have 1 minus 1 plus I minus N. Right, let me see. Cool stuff. So let's substitute. What's happening here? Hey bro, cool. P, that is 748. Then I, the interest I think is 9 something, 9 per annum compounded monthly, so it's 0.09 divided by 12. Right, and then we're gonna have minus 12 times 20 because it was for 20 years, ne? Sure. Calculator, do your thing, bro. Okay. And therefore she will be paying 6,729 rand 95 cents per month. Yeah, that's how much she will be paying per month. So now we have, how much interest will she pay over the duration of 20 years, ne? So for the duration of 20 years, we just say find out how much she paid, ne? Right. Okay, so the interest, ne? Interest is going to be total payments minus what the loan was, ne? Just for this question, loan amount. Funny. So you have 6,729, and there's a 5 there. Then we are multiplying it by 12 for 12 months, multiplying by 20 for 20 years, and the money she would have paid had she not taken the loan. You even see that the value is quite higher. Then we subtract the 748 and wait, cool. So that is the value, that is the amount that our lady here, our lady here paid the interest of that much. Our lady paid that much interest. So yeah. Let's see the next question. This was the interest. Oh, to the nearest rand. Oh, it's actually even. So cool. Calculate the balance of her loan immediately after. Cool. Yeah, cool, ne? So for this question, man, for this question, when we for us to calculate how much she still owe immediately after her 85th installment. Yeah, there are many ways in which you can think about this one. There are many ways in which you can think about this one. The first way is uh so think of this as a future value annuity type of thing, right? Where you are putting money into a savings account, so you can calculate how much all these 85s, what do we call it, payments, how much they were, how much they equate to. Hmm. Yeah. Just find out how much they will be equal to, right? And then, and then, you calculate how much, right? How much money the loan is going to be. Yeah, in a sense of, remember the banking systems, ne? What they charge you is when they give you the loan, ne? And you are promising that you're gonna pay later. So we check to say, okay, if you decide to pay us 10 years later, like the full amount, in 10 years' time, how much is the current amount you are taking from us? How much will it be worth? Yeah, but so it's like I invest this money, or I make calculation to see if I invest this money for this long, how much will I have? Then I know the exact value of my 100 rand today, and then I can judge you based on that. Yeah, but so that's the idea. So, an example. First thing you'll do, let's find out how much is the loan going to be, uh, in this time. Yeah. So you do your calculation to say A P1 plus I N. Yeah, so you have your formula there, right? So let's put in the values. It is the 7748K. Remember, 9% compounded monthly to the power of 85, ne? And then this 85, remember the whole reason we say n times 12, right? We are saying the number of years times 12 because, well, let me just speak in general terms and making times m. This being how many times is, yeah, well, the interest being compounded. Yeah, so the idea is that in our case our interest is being compounded monthly, so it's like, yeah, so that means the okay, you're going to gain the interest, right, 12 times a year, right? Or basically here's a beautiful explanation. Basically is the thing of, what's the beautiful explanation, bro? In our case, the interest is compounded monthly, right? So then this becomes the number of months, right? So we just leave it here. It's the number of months, so we're not going to do anything to it, you see. Also, like from our previous calculations when we did 20 times 12, this is the number of months the compound was, the interest was compounded. But yeah, let's calculator do your thing, bro. And so we are getting 1 million 411. So here it's like the bank is saying, look, bro, we don't mind borrowing you some cash, but if you want us to borrow you that 748,000, the thing is, in 85 months in, yeah, in month 85. Right, that 748,000, it will be worth 1.4 million to us. Right, so we don't want to rob ourselves. Yeah, we don't want to rob ourselves. We want it back as something close. So here what I am basically doing is I'm just finding out how much is that amount going to be. Now what I can do is I, so now we have the formula. Let's use the future value formula, which is going to be, I'm copying it from the site. I actually don't know this one by head, which is bad representation of what I've been teaching. I must know this thing by head. I n minus 1. Cool. So now the question is, how much am I paying? Oh, I think, okay, I was making it 6,000. 6,000. Let me pause. Yeah, so the value that I am paying is 6,729, right? 95. That's the value we calculated, or the value that we had after our calculations, right? 12, 80, 85, right? Yes, sir. Oh, yes, ma'am. Then we have right. Tata 1 plus close to the power of minus 1, then close 0.09 divided by 12, and the amount is what? 796 153 96. All right, so with this value now, what we do is then say, therefore the remaining balance, the remaining balance is just going to be the million. Okay, cool. And therefore the amount that still remains is that much. It's 615,509 and 78 or 77 cents. Right, that is the amount that would be left. Right, so I'm not happy with the way I explained this one. I am not happy with the way I explained it, but let's say is there's another explanation I can offer. Right, let's think of this formula of the present value annuity. Right, let's think about it. So if I have X, right, which is the amount that I am paying every month, and if I make my calculations of X, so I substitute X and I substitute the interest, and say I'm making the payments for 3 years, so it's 3 times I'm paying monthly. 3 times 12, right? So what that formula is going to give me, it's going to give me the amount of money that I will have to, that I would have paid, right? Yeah, it's the amount of money that I would have paid by the end of by the end of the third year, like all of the money. Does that make sense? The amount of money that I need to pay. Yes, the amount of money that I would have paid. Yeah, that makes sense. I don't know. Hopefully, it does make sense to you. So, now, in a way, I can also phrase it and say that that same amount is the same amount of money that if now, I say I start paying now and I have 3 years to pay this money, right? I can say the money that I have remaining, right, or the money that I need to pay, right? I use the present value formula, present value annuity formula. I use that formula, put in X, I, and N, and then it's going to give me how much I have left, right? So yeah, so it's going to give me exactly how much I have left. And with that being said, I will leave the final balance here just for comparison. And let's use our present value annuity formula. So for present value annuity formula, we have PV equals to X. I think this is 1 minus, yes it is, I minus N, right? And then now when we make a substitution, it's 6,000, 6,729. Yeah, I think it is 6,729. Let me force and look back. Yeah, 95 cents. 1 plus 0.09, 12, right, minus, I'm coming there. Let me just close it, but I'm gonna put a value here. So I'm gonna put a value there. So I have 0.09 divided by 12. Cool. So the value there, the question that was asked is like, how much money do I have remaining? Remember, I have made payment 85 payments so far. So, and the thing is for 20 years, so I can say that minus 85, and that's how much will be remaining. So that's, yeah. So this formula, it must give me this value right here, right? Yeah, it has to. If it doesn't, I did something wrong. And I will have to go and fix that thing. But I doubt. Let's see. 1 minus minus 155. Close bracket. Damn. Okay. It's a good day for me, bro. So we have 615, 509, 73. Cool. So yeah, so you see, bro, like the same. So we good. I am very happy that I got it right. It was gonna be a very frustrating moment if it was wrong. Cool. So we did calculate how much money is remaining. Cool. Now it's like she experienced some financial difficulties after the 85th installment and did not pay for 4 months. So that is 86, 87, 88, 89. And then they like calculate how much Sipho Kazi owns on her bond, right, at the end of right? 49, right? So this is like during the time when she didn't pay. How much does she owe now, right? So remember, after the 85th installment, yeah, after she made that 85th payment, she had this much remaining. And if she doesn't make any payment on the debt, this money is going to grow, right? So that money is going to grow, right? So we use it. And then as for the number of periods or the number of months the payment didn't go through is 4 months. So yeah. Cool. So now her date will be 634 1837 8. This is now how much her debt will be. And then she says she increases, or she decides to increase her payments to 8.5 per month from the end of the 90th. Oh, yeah, okay. How many months will it take to repay her bond after the 85th payment? Cool. So now you're just finding out how many months, right? We're still going to use which formula? Is it the future or the present? It's the present. Why? We're dealing with debts, ne? Cool. So that formula, remember, PV x1 right, and on the formula we are looking for x. No, we are looking for n. So PV is 6. The money that she owes right now, 634.8. How much she's paying right now? 8.5. Oh, 0.09 12 minus n, right? So now to continue, this is just solve for x, ne? Yeah, this is just simple solve for x. So I'm seeing, okay, this is over 1, this is over 1, so if I cross multiply, I'm gonna have 64183 times multiply by 0.09 by 12 being equals to 85. In fact, let me divide by 85 already. 85, right? 8.5 might not 85, or I can just say 8500. So that means here I have 1 minus 1 plus 0.09 12, and then minus n. So in a way I can say what I have is 1 plus 0, let me see, 1 plus 0.09, when I say 12, it's not a big number, right? 1 plus 0.09 for 12. Cool. So I'll just say 403 over 400 to the power of minus n is going to be equals to 1 minus, so all of this I'm going to put it in a calculator, see how much I get. 634,183 times 0.0912. Cool. So I am getting there. Usually if I get big numbers like that, I don't know, I would do this. I don't know, I like, yeah, ne? Right, so then with this case I can use log and say minus n is going to be log, this is the what, this is the base, which is 403 over 400, and then 1 minus multiply by 500 close bracket. So log 403 over 400 634 all right, and I am getting minus 109.744. Right, and the question, did they say to the nearest anything? How many months will it take? Right, so here, bro, it will just depend on how you interpret. So you have minus n, so I'm tempted to say, okay, look at this, né? So we have 109 months that we are very sure of, right? And then the comma is a couple of days, right? In a month, right? So we have 109 months we are very sure, and then the comma, like that, 0.7444, it's just a couple of days, which those couple of days, if it's just 28 days and it's February, you see, so this one, you can then say, and therefore n equals to 110 months, right? You can either say n is 110 months, or you can actually try to find the exact number, which this 0.744 you will try to find. I mean the number is big, maybe you can put a 5. You can try to see how many days of the month is this 0.74, right? Yeah, let me actually check something. So 28 over 31, okay, but yeah. Thank you very much, guys. I'll see you in the next chapters.